Welcome back for part 2 of the Exam 4 review for Math 310. Solve and check the following equation. So we have 4 times something in parentheses minus 3 times something in parentheses equals negative 8. And like I said earlier, it's safest to change subtraction to addition, which you do by changing the minus to a plus and assigning a negative sign to the number. So let's distribute the 4, and we have 4x minus 36 plus, and then we have negative 3x plus negative 21 equals negative 8. So now we combine like terms. 4x minus 3x is x. Minus 36 plus negative 21 is minus 57. I'm going to say plus negative 57 equals negative 8. So let's add 57 to both sides. And we get x equals 49. Now let's check our work. We rewrite the original equation. Instead of x, we're going to put 49. And we're going to write it exactly like it started out. And this is a very good thing to do, especially if you're not totally confident about your handling of negative numbers. So we have 4 times 40 is 160, minus 3 times 56, which is 168, equal to negative 8, and 160 minus 168 does equal negative 8, so it checks out. So our solution is 49. Here we are to solve, write an interval form, and graph. So we have an OR that's going to include both conditions. 2x plus 1 is greater than 5, so 2x is greater than 4. We're subtracting 1 from both sides. Or 3x plus 4 is less than 1, so 3x is less than negative 3, subtracting 4 from both sides. And now on the left we'll divide by 2, and on the right we'll divide by 3. So we have x is greater than 2, or x is less than negative 1. So x is less than negative 1 is right here, and x is greater than 2 is right there. Now if this were an AND, then we would have an empty set for a solution because they don't share any solutions. But it's an OR, so we can go right from our number line to our interval, and we write negative infinity to negative 1 union 2 to infinity. We are to solve this, and this is mostly an exercise to make sure we don't make mistakes with our negative signs. So in that spirit, I'm going to change any subtractions I see to additions. Now I'm also going to change my negative sign to a negative 1. So we're going to multiply everything by negative 1. So negative 1 times negative 5 is positive 5, plus negative 1 times y is negative y, plus 7 plus negative 3y is less than negative 4. Now I combine like terms. 5 plus 7 is 12. Negative y plus negative 3y is negative 4y. And then I subtract 12 from both sides. And now I'm going to divide by a negative number. So that means I reverse my inequality. And I get that y is greater than 4. So that is the answer, but it's not in the right form. We need to put it in interval form, and we need to graph it. So first we're going to graph it. We have 4, and we know that y is greater than 4, not greater than equal to. So it looks like this to graph it, which we do first because now we can write down the interval by just looking at it. We see that the left boundary is 4, and over to the right it goes all the way to infinity. To solve this, the left side is simplified already, so we combine like terms in the right side. So we get 4 minus 5x equals 3x plus 4. To get the x's on one side, let's subtract 3x. And we get 4 minus 8x equals 4. And then we're going to subtract 4 from both sides, so that the x terms are on one side and the numbers are on the other. Now you have 8x equals 0 or negative 8x equals 0, and when you divide 0 by negative 8 you still get 0. So x equals 0, and that's the solution. You might think that the solution is either an infinite number of answers or no answers, but that's not true. 0 is an actual value that x solves to equal. In this absolute value inequality, we have a less than or equal to sign, and that means we are going to end up with a compound inequality which is bounded on the left and the right, and I'm going to show you what that means. So first, to simplify this, we want to get the absolute value by itself, so we subtract 4 from both sides. And then we have two cases. M plus 7 is less than or equal to 24, and the other case is m plus 7 is greater than or equal to negative 24. And what we're saying here is m plus 7 has to be between negative 24 and positive 24. So we subtract 7 from both sides and we get m is less than or equal to 17 over here, and m is greater than or equal to negative 31. So what that means is when you have a less than or equal to or less than, you have an and situation where both conditions have to be true. So here you have 17 and here you have negative 31, and m has to be greater than or equal to negative 31, and it has to be less than or equal to 17. So it's going to exist in here. And the way you write that interval is simply negative 31, 17. So when you have a less than or equal to sign, then you are going to have this kind of situation where it's bounded on both sides. And if you picture this on a number line, let's say that you have the absolute value of x is less than 3. And here's 0, here's 3, and here's negative 3. What you're saying is that x cannot be more than or equal to 3 units away from 0. So x has to be in this area or in this area. And so that's the same kind of scenario. Here's another situation where we need to know if it's conditional, identity, or contradiction. If it's conditional, your W is going to equal a value, like a number. I'll just say a number. If it's an identity, you're going to have something on the left, 3 equals 3, or something like that. And if it's a contradiction, contradiction, an example would be when there are different values on either side. So let's see what this is. We distribute the 17 and we distribute the 6. Then we combine like terms. Okay, now I can already tell you that this is a contradiction. Notice that you have 12w on both sides. Let's subtract 12w. So if you subtract 12w from both sides, you end up with 34 equals 13. And that's false. So that means you have a contradiction. Okay, here's another situation where our absolute value is bounded. It's less than or equal to a certain distance from 0. So we're going to have a lower value and an upper value. Infinity won't be involved, and it won't be a disjointed interval. Okay, so this tells us that x plus 6 is less than or equal to 3, or x plus 6 is greater than or equal to negative 3. Subtracting 6 from both sides, we get x is less than negative 3, or x is greater than negative 9. So here's negative 9 and here's negative 3. We're going to have brackets because it's less than or equal to and greater than or equal to. And then everything in between is going to be filled in. So our interval looks like a bracket, negative 9, negative 3, and a bracket. Here's another interval where we have a less than, an absolute value that's less than a certain amount. So again, we're going to have a contained or bounded interval. So we have r minus 1 is less than 7, or r minus 1 is greater than negative 7. Adding 1, we have r is less than 8, or r is greater than negative 6. So here's negative 6, and here's 8. So it's less than, and there's no equal component. We use parentheses instead of brackets. And our interval is going to be negative 6, 8. Okay, in this one, no absolute value is required. If you'll notice, we have 13p on both sides. But there's something interesting here. First of all, I'm going to slow you down a little bit. What if this had been an equal? And we subtract 13p from both sides, we would get minus 5 equals minus 8, and that's not true, so that's a contradiction. But it's not an equation, it's an inequality, and so something else is going to happen. So here we have 13p minus 5 is greater than 13p minus 8. Subtract the 13p's, and you get minus 5 is greater than minus 8. And that's a true statement. So that means that every value of p will work for this. So your solution interval is going to be negative infinity to infinity, and your graph is going to just be negative infinity to infinity. Here we have an absolute value equal to an absolute value, or a distance equal to a distance. And to solve for z, we need to do our same procedure, which is to set the contents of the absolute value equal to the positive version of the right side, and also 7z minus 1 equals the negative version of the right side. I'm having too many negatives. Okay, so on the left we we add 1 to both sides and we get 5z plus 4. Subtract 5z from both sides and we get 2z equals 4, and then divide by 2 and we get z equals 2. On the right we have 7z minus 1, and let me go ahead and distribute that negative sign. So we add 1, and then we add 5z to both sides, and that gives us 12z equals negative 2. So z equals negative 2/12 when we divide by 12, and that makes z equal to negative 1/6. So our solution set is 2 and negative 1/6. A union is when you combine things, and to find a union you combine the members of both sets. So before we had an intersection problem. This is not an intersection, it's a union. So we'll start with the smallest number, 2, 4, and 6 occurs in both 7, 8, 9, 11, 12. So we had all of the numbers, but we only have them occurring once, and that is the union. Number 28 tells us to express the set in the simplest interval form. And I went ahead and drew lines so that we could plot these first on the number line and look and see what they look like there. We have the interval that runs from negative infinity to negative 2 intersecting the interval that runs from negative 11 to infinity. So first let's graph the interval that runs from negative infinity to negative 2. So it's going to run from negative infinity, and we'll say negative 2 is right there. And at the negative 2, it has a bracket. Now let's do the other one, which runs from negative infinity with the bracket. From negative 11 to positive infinity. We are looking at the intersection. We're not looking at whatever's in the total of both groups, but we're looking at those points that are in both groups. In other words, an intersection has to exist in both groups. So if you look at the top line, everything I'm doing in blue does not exist in both groups. If you look at the bottom, everything I'm doing in blue does not exist in both groups. So what does exist in both groups? And that's going to be everything from negative 11 all the way to negative 2. So what we have in red is a plot of the interval that is the intersection of negative 11 to negative 2 intersecting with negative infinity to negative 2 intersecting with negative 11 to infinity. So the red is that intersection, and to express it in the simplest interval form, we would write down what we see, negative 11 to negative 2. Now it's possible to go straight from the problem to the solution, but it's better if you graph it because then you can see visually what you're doing. And that brings us to the end of our review for this exam. Now, as you're preparing, I urge you to take at least 3 practice tests, and if you pass all of those tests, you're probably in good shape to go take your exam. But if you don't, then I would recommend you use the study plan, which will create problems similar to those that you missed in your practice tests. And to find out how to use the study plan, go to course documents and right at the top of it is the form, how to use the study plan. Good luck.